I'm Emily Hoogenbrook. I work in the ZVM memory management team, but previous to that, I've worked in a number of different areas in ZVM, including systems management, and I started in test. And so the reason that I developed this presentation is because starting in test, you get the opportunity to get used to a lot of different problems and how to take different types of dumps and collect information and what kind of information is best to collect when. But that's a pretty unique opportunity for test. And obviously when you're in the field and something is going wrong, it's a little bit more difficult to think of, what type of things should I collect, or maybe you've never taken things like a snap dump or a PSW restart dump before, and you're not quite sure what to expect in terms of, what messages to get or what's going to happen when you do it. So I developed this presentation just to give you an idea of some of the different ways that you can collect information and what that will look like and what to expect. Of course, we hope that you never have to deal with any of these, but if you do, here's what you should think about. So thanks to a number of different people from our test and our service groups for their help on this one. There are slides that I'll go through, and then there are also a whole bunch of backup slides with different information about some things that we probably won't have time to get to demos of. And so I tried for everything. We're taking a dump or collecting information to put sort of step-by-step with screenshots into the deck. So hopefully you can use it as a reference guidebook, and we'll definitely put the PDF out afterwards. So the first thing that I know from being a tester is that what you see going wrong is not necessarily the thing that is actually the problem. More often than not, you see the symptom first, and it gets really tempting to sort of hunt down that symptom, but oftentimes that's not the real cause. And so the example that I like to start with this presentation is, let's say you have a Linux guest that has a ping timeout. So you've noticed that whatever application it's running doesn't work anymore. And so as the system administrator, system programmer, probably the first thing you do is try to type in a ping. And so we're going to look at that ping timeout in sort of various levels of how bad could the problem actually be. And so we'll start with the easiest, sort of just a networking problem on that Linux guest, all the way to the most dire, which is something is actually wrong with the ZVM system, and we'll get into something being so wrong that we actually have trouble taking a dump. And so the first thing is, if you can't ping to the guest, you're probably going to try to go and actually log on to the ZVM user ID. And so we can do that here. Yep, here is my Linux guest. So I brought up a ZVM logon screen, and I've logged on to my Linux guest. I can see it is actually up. This is quite an older Linux guest, so I'm going to do an ifconfig, and yeah, he doesn't look like he has any networking defined. If I'm actually logged on to him, I can do various commands, cp query nick or a cp query vnick. And so this is obviously the problem with this particular Linux guest. I've chosen an old one where I had to give up the networking connection for him. So the reason that this guest can't ping is that he doesn't have a virtual NIC, so that's pretty much the end of any networking for him. But, for your Linux guests, there might be something else wrong. Maybe you want to try something like a query vSwitch, and that'll show you the different vSwitches in the system, show you if they're connected to OSAs. Common problem, too, that I've done many times with Linux guests, where I've put in the wrong OSA address or had an OSA that's not connected to the right subnet. We've all done things like that. So hopefully just a configuration type of thing, something that maybe you can figure out from a couple CP commands, maybe something where you can ask your networking folks to make sure and check that the OSA is connected to the right subnet, that you're using the right OSA, that your vSwitch has the proper settings that you expect for it. So we hope that that's all it is. But let's pretend that you tried all of that and it still isn't working. And so maybe instead, when you go to try to log on your Linux guest, you're on that green screen connection to your VM, and you don't get the Linux login prompt. You don't get any kind of response from Linux. It seems like the guest is hung, but maybe you can still do like a #CP and issue some CP commands, but it seems like Linux itself isn't up. That's probably getting into more of a Linux problem. So you can use actually the CP command system restart, and that will send an emergency signal to your Linux guest. And if you have it configured properly with kdump and everything like that, that will cause the Linux guest to automatically create a dump, which then you can send into the Linux team. You can also use standalone dump, which I'll describe how to do in a bit for a ZVM system, but it can also work for a Linux guest to get a dump of your Linux guest. So in that case, the only thing wrong is sort of within the guest. Something has gone wrong within Linux. So it's still a fairly targeted kind of a problem, not affecting the whole system. But let's say that's not your problem. Let's go down the next level deeper. And so you're trying to log on and it's not working. Maybe you've already collected whatever data you can about the guest. The way that you want to restart your guest, you've probably used these commands before with force and xautolog. Force is going to send a signal shutdown to Linux. You might notice that force doesn't work. It'll have some amount of time, and you can query this with the CP command query signal shutdown before it tries to give the guest to log off. And so, yeah, you might see you send it the force command and you don't see anything for a while. And then all of a sudden the guest logs off, and that's the signal shutdown. So in that case, maybe just logging your guest off and logging him back on, turning it off and turning it on is always a good thing to do with IT problems, right? Maybe that will clear things up. Something that happens occasionally when we have guests that are very much hung, and they're hung not at the guest operating system level, but at the next level down, something in the ZVM control program is hung up. You might see that it seems like the guest logged off, but he's still logged on. You sent him the force, but then you do a query names, you see him still there. You query the particular guest user ID, and it has this weird log off force pending. So this is getting down to the next level of problem. So that means that there's something in the control program that's not letting us finish logging the guest off. And I've seen this a decent amount with problems on devices. So maybe we have some kind of outstanding I/O that we can't clear up. Maybe there's something, right now I work in memory management, so we think about some paging problems that are happening. Again, in the real world, these are kind of rare, but here in the lab, we see them a decent amount. And so once you're getting to something that's log off force pending, unless it's really kind of just device related, probably going to require an IPL to clear. So now we're getting down into the sort of meatier problems that really involve the ZVM control program. Meatier from my point of view, I should say. If you're a Linux expert, then obviously that stuff with taking a Linux dump was quite interesting enough for you. So let's talk about this problem. Either the guest is in log off force pending, or you're having trouble logging on to the ZVM user ID. So, you can't actually finish the logon process. Maybe it kind of hangs on the logo screen. So maybe what you can do is log on to a Class A guest. And so your Class A guests are things like operator or mate, somebody that you use for a lot of important system stuff. I happen to have operatants here, and you'll see why in a bit. I do a query priv class. You can see, again, it's a test system. He's got lots and lots of privileges. So he can query, this is my Linux guest. Obviously, I'm still logged on to him right now, but I can start to query and look at it. I can do the force. And here we see the termination might be delayed. But there you can see he finally got logged off. timeout expired or he finished his shutdown and it was safe to log him off. Now, a lot of times, if the guest was logged off and then we go and log him back on, we might want to collect the spool console from that guest. That can tell us a lot about what was going on. And so you always want to have spool con start somewhere in the guest directory entry or profile exec. And I think Bill mentioned that Tracy Dean has been talking to you. So if you have operations manager, that's really great because that does all of that for you and you don't have to worry about collecting it yourself. But in a pinch, it's good to know how to collect it yourself. In this case, he did not have anything for us to look at. We can go back. And log on to our Linux guest. And he's coming back up. So that just shows you how you can do a force and xauto log and get the guest back up. So again, let's go a little bit deeper and say what happens if that didn't work. And so the guest at this point, our imaginary guest, is still logged on and hung at the ZVM level, but maybe you were able to log on to another user ID. And so it's not the entire ZVM system. It looks like it's just this one particular guest. And so what we can do next is get a snap dump. Snap dumps are really powerful because they allow us to get a snapshot of the running system without really disrupting majorly all of the guests on there. There does have to be a little quiesce period, but it's not like an IPL. Things don't generally have to get restarted afterwards. And sometimes if you have a log off force pending guest, particularly a snap dump can kind of clear things up at the same time because we have to do a quiesce, like I said, of the whole system. So sometimes that might be enough to get a hung guest back up and going. And it has the added advantage that we get dump at the same time. So you can send that into the ZVM team for us to look at and determine what the problem is. On 7.1, we added some new options to the snap dump command, PGM blocks all and frame table yes. And because I work in memory management, I really like always using these. These are some memory management structures that on one hand make the dump larger, on the other hand give us a lot of important information about memory. And if you have a hung guest, we don't know where the problem is, right? So if you have enough space to collect these, and like I said, if you're running a large system, like a 2 terabyte system, this could be very, very large. But if you can do that and collect this information, this can be especially helpful to us. So I'll show you now what a snap dump looks like. And so again, I'm going to go back to my Class A ID here, operatins, and issue the snap dump command. And this is one of those things that scares me at first because you saw that I got the little X in the bottom and it seemed like the system was not responsive. Now it came back pretty quickly. This is a test system and I reserved it this morning so nobody else is on it. So it's pretty quiet. It's pretty much just my Linux ID and the usual guests. So there wasn't a lot to dump. But again, if you had a large system, that quiesce could be longer. And it's a little bit frustrating because you don't get this message then until the system kind of comes back, that the system will be quiesced until the dump is complete. So the main thing that I think always catches people off guard with a snap dump is the fact that you do have that quiesce right when you issue it. And I happen to be on operatins for the very simple reason that this is the user ID that's going to collect the dump. So he has a lot of good things in his profile exec that he runs, including a query of his own reader. And you can see right there is our snap dump. And you can see the date and time of it. So that shows that, yep, we literally just took this. And in this column here, you can see the type of dump. And so a snap dump is always going to show as an SMP 001. Now, what to do with it? It's not much good to us in the reader. And so you are going to have to load it onto a disk. So you probably want to do a query disk and make sure that you have something with enough room to load it on. I've set this up nicely so it has a nice big A disk. And then we use the dump load 2 in order to load it. Now, there are a lot of options on dump load 2. The nice thing about dump load 2 is that it allows a dump to be chunked up into smaller pieces, and you can say exactly how large you want those pieces to be, or it will automatically suggest one. I'm just going to let it take the automatic suggestions here. So it found that dump in our reader, so that's good. And it's, like I said, it's not very large, so it can do it all in a single dump file. So I'll tell it to continue. And again, this is a step that's going to take a little while, depending on how large your system was, depending on how much was going on your system. You know, if you have a 2 terabyte system, but you only have 10 small guests logged on, probably won't be that much. So we'll let that go in the background. If you're wondering which ID the dump is going to go to, it is generally operators, but you can set that, like a lot of things in ZVM. In the system config, there's a system user ID statement that says where dumps go. And so this is just showing you that dump load 2 output. One thing that has happened to me a lot of times is that I have forgotten to check how large my A disk is before I read it in. And I fill up my A disk, and then I have to go back and reload the dump. And what I'll find is that then I issue dump load 2 a second time, and it says no dumps found. And I say, wait, I know I took a dump. I just tried to read it in, and it failed. And that's because after dump load or dump load 2 attempts to load it, it's going to change the hold state to user. And so what you want to do is do a query reader star all, find your dump. In this case, it's a VM dump file, not a snap dump, but same general idea. And then take a note of this number here. That's the spool file number. And you'll need to do a change reader, whatever that number is, no hold. And then you can load it again, and it'll work. So there it is. We look at it on our disk and see it's right there. Now, if you want to look at it on your system, you can definitely do that yourself, or you can just send it in to our service team. The way we look at it is VM dump tool. And so that tells us a little bit right up here about the system. So it's a 7.1 system. This tells us when the CPU load module was generated, when it was IPL'd, and then when we took the append. You can see how many CPUs were online. You can see one macro that I like is the trace all, and this shows me the last 5 trace entries on each CPU. Like I said, you really don't have to do this. You can just send it in, but if you're curious to poke around within the dump, you can do a VMD scan, and that's going to show you all of the users that were logged on to the system. So there's our Linux guest, there's our operatants. See, he's selected because he was definitely doing something at the time of the dump. And so sometimes the user state can give you a clue to what's happening. I can look at a particular user, and it will give me some more information about it. And one thing I like to look at, especially when I have a hang, is these outstanding CPE blockchains. They're sort of blocks that we use to keep track of work within CP. And so here you can see it's processing a command, HTTP CMD, and in fact, it's HTTP snap command. So there you can see the snap dump command and how it actually looks. I like dump summary because it gives me a little summary of the system, whether we were running first or second level, storage, CPUs, this is the CPU type, and then the name of the IPL module. Sometimes I like to just look at dump in dump tool on the test system before I go ahead and send it in, just to make sure that it actually took the dump correctly and it's readable, because it does take a while sometimes to FTP stuff in, and you hate to do that if it turned out that the dump wasn't readable. So that's taking a snap dump. So another thing that can happen that can kind of look like a hung user is that the SSI can become unstable. And I think you're probably all familiar with our clustering technology, single system image, and this idea that up to 4 ZVM systems can be hooked together and sort of operate as a single system. If things happen with the communication there, or maybe access to certain important disks are lost, then it can go into what we call a safe mode or an unstable mode. And that will have the effect that you can't then log on to user IDs that are sort of everyday user IDs. You can still log on to these identity virtual machines, mate or operator or operators, but probably things like your Linux guests and things like that, they're probably the regular single configuration users. And so you'll note that you can't log on to those. So a good thing to do, if you're not sure, is just to do a query SSI and just make sure that the SSI mode is stable and all the systems you expect are joined. Particularly if the links went down, the CTC links, you can reactivate them using Activate IS link, and everything would go back to normal. You'd be able to log back on your guests again. Like I said, again, fairly uncommon in the real world, but something that happens every once in a while in the lab. So I always like to just check the SSI state. So let's go then to the next sort of level if we go back to our imaginary thing where we started with the Linux guest that it couldn't ping to. Let's say we couldn't log on to the Linux guest, and then maybe we tried to log on to mate or operators or operator or something. We couldn't log on to that either. And so maybe we can't even get a log-on screen, a logo screen. And so at this point, I would probably go for a PSW restart dump. So this is something that you're going to have to do from the HMC or SE, which hopefully if you're a system administrator, you have access to. This is going to restart your system. So if you happen to have any work that's up and running on it, you definitely want to let those people know. It is kind of a big hammer to use, but if you can't log on to any user IDs, that's kind of what you're going to have to do. So here we have an HMC, and there are different styles of HMC, so yours might not look exactly like this. You might be using DPM or something like that instead. But what you want to do is select your LPAR. So this is GDLL CPX3. And I could tell that that was the same because that was the SIM ID in my lower right-hand corner. Again, if you're doing this, you want to be really, really sure that you know which system you're doing it for, because also done that as well where I've accidentally restarted somebody else's system and then they're not very happy with me. And so then I click in recovery, PSW restart, and it's again going to make sure that I really know which one I'm doing it on. So it's going to tell me which object. I'm going to say, yes, I really want to. And then it's going to warn me again, because like I said, this is going to restart everybody on that system. So it wants you to be really, really sure. I'm sure. So go ahead. And it says restart in progress. And then it says success. All right, so is it back up now? If I, go to my user ID here, go back to my system. I still can't get to it, but it said it was successful. Well, one thing I like to check in here is the operating system messages, being a little bit slow this morning, but this should show us the system actually restarting and what that success message actually meant. And it took a little bit to get it up here, so the system has actually restarted now. But what the success message here means is that it successfully sent it the signal to do the PSW restart. It does not mean that it successfully restarted. And so you could see for a while the status, I think, was exceptions as it was coming up. And if we had gotten this up a little bit faster, we could have watched it scroll through the actual coming up. But here you can see it's rejoining the SSI cluster, logging on all of the usual user IDs like TCP/IP and all that good stuff. And it's back up. But depending on the emulator you're using, might get a little bit hung up there. No problem. I just use regular TCP/IP to get back to it. So I'm going to log back on to Operatins. And now, when I log on to Operatins, it does a couple queries as it comes up, and you can see that the last start was a system restart after system failure SVC002. So that's the ABN code that you'll always get for a PSW restart. Now, if you recall back a while ago, I mentioned that if your Linux guest is hung, you could do a CP system restart command. And so that is actually sending the Linux guest the same type of signal that the HMC just sent to our LPAR. And so if you had, for example, a second level ZVM guest, you could do the system restart first level, and it would spark a PSW restart dump, this SVC002. And you can see there it is in our reader. You can see our snap dump is still there too. And because we loaded it in, the snap dump is now, like I mentioned, in user hold. And so now if I do a dump load 2 again, you see it's going to ignore that snap dump and find my SVC002. And okay, it wants me to do an order reader. That just puts it to the top of the reader queue. And because it hadn't actually started reading in that dump, it didn't put it in hold, so I was fine to do that. If at this point it stopped because the disk filled up or something, then it would be in hold. One thing I want to mention is that was showing how to do a restart dump from the HMC. It's a little bit different from the FE, if you're familiar with that. In that case, you have to select your LPAR, and then you have to actually go in and select a particular processor to target with the PSW restart, and it's under CP Toolbox, not under Recovery. And it doesn't really matter which processor you select it to. I suppose if you had gotten particularly unlucky and you had a single processor that was hung and you selected that one, that would be bad. But in general, whichever processor receives the signal will start the dump. So you don't have to worry about particularly targeting the master processor or anything like this. So now I mentioned before when we were doing the snap dump about wanting to do a PGM blocks all in frame table yes. There's no, obviously, setting for that on the HMC SE. Instead, it's going to obey what your dump settings were. So if you do a query dump, you can see what it's set to, and generally they're set to the default. With the default, it depends on the ABN code and whether it's an ABN that we know needs those or not, because there are obviously a lot of different things that could cause you to take a PSW restart dump. We don't generally dump the PGM blocks in frame table. If you had extra space and you wanted to be super nice to us, again, since I'm in memory management, I'd appreciate seeing the PGM blocks in frame table set to all and yes, respectively. But again, not everybody has the space and time for that. But it's really something to be aware of on 7.1. If it happens to be something where we do find we need that information, we might be asking you for a recreate. So let's go back and check. Should be all loaded in. We can just do another VM dump tool there. You can see here it looks a little bit different on our snap dump. Our last trace entry had said something about taking a snap dump. Instead here, our last trace entry says something about entering a wait state. And again, that's just a matter of a different type of dump causes some different trace entries. So let's go ahead and talk about the really big hammer. There are some times, and they're really rare even in the lab, that a PSW restart dump is not working. So these are dire times, something perhaps is in a super tight loop in CP, something has gone extremely wrong, maybe there's a hardware component to the problem. In that case, it's time for a standalone dump. And unfortunately, by the time you get to needing a standalone dump, it's too late to have thought about a standalone dump. And the reason I say that is because there is actually some work that you need to do to prepare standalone dump disks before you have a problem. So if you have not gone through these instructions, I think that there is a reminder in the ZVM install guide and things like that. But I know sometimes we all skip over the fine print. But now is a really good time to go back and look through Chapter 11 of the CP Planning and Administration Guide and go through what you need in order to set up for a standalone dump. You'll need entire devices, so that would be an entire 3390 disk of any size or an entire SCSI LUN. You might need multiples of them. A lot of this depends on the size of your system. I think there is some guidance in there on what size you would need. And it takes you through exactly how to set those up. And there are some image files. And so what this is setting up is actually a sort of standalone operating system that's going to take care of dumping memory for us. So basically at this point, we're so messed up that we can't be trusted to take a dump of our own memory. We need a helper to come in and dump it for us. So this is where it gets a little bit exciting. So like I mentioned, this is actually bringing up another operating system. And so instead of using anything sort of recovery-based, we're actually going to use load for this because we're actually loading another operating system into the partition. Important thing that we want to do here first, we want to do a stop all processors. This is really important because we're loading a new operating system. If there were anything kind of up and running, then it could interfere with the load and we'd end up with junk that was really not readable. So first we're going to stop all processors for our LPAR. And again, the HMC and SE are very safe about this. So they ask you a bunch of times to make sure that you're sure. And we see it says success. And we go back and it says status not operating. So that tells us that our processors have indeed been stopped. Now I'm going to bring up load and I'm going to pause here and get out a pencil and paper, which of course you can't see, but I have it right here. And I am going to write down a few things from the screen, or alternately, I could take a screenshot and save it somewhere. But I'm not going to want to forget the load address because this is the load address that my ZVM system is actually loading from, or the load parameter, which is the console that my system is going up to. So I want to make sure that I write those down because I want to bring my ZVM system back up after I do this. So now that I have 51 Fox 0 and 020 written down, I'm going to get rid of that. And instead, I'm going to put in the load address of my standalone dump disk. I'm going to clear out the load parameter. I don't want it going to any console. I'm going to click Store Status. Sometimes when I talk to new testers, we get super tempted to hit this, like, clear the main memory on this partition before loading it because we think, oh, you know, like we're sort of clearing out main memory and getting something in, or maybe we think it'll go faster. That is one thing you absolutely do not want to check if you're taking a standalone dump, because that will clear out all of the data that we want to dump. You do, however, want to check store status, because that's part of the magic of what's going to make this work. So now that I have my standalone dump address in there and store status and no load parameter, I am going to let it go. Now you do have to update your standalone dump disks periodically. You know, when sometimes on a new release boundary and things like that. So This is something you want to kind of keep in your mind in the background. Okay, there we go. And again, it's going to ask you many times, because if you were running something that you cared about, this would definitely restart it. And so you can see you might get a little bit scared that it says function duration time is 1 hour. It should be something less than that. If we switch back over to our operating system messages, we can actually watch it taking the dump. So you can see it's starting standalone dump, dumping frame table. That's a frame table, yes. You definitely get that with a standalone dump. But this was pretty fast because it's not that big of a system. And so you can see standalone dump was successful. So now we need to go and load it again to bring our ZVM system back up. And this is where my paper comes in handy, because I wrote down the load address and parameter. I'm going to put it to sysc. I believe that should bring it up on operating system messages. And it'll load it back up here. There it goes. I do need to enter force here. This is like I said, a pretty big hammer to use. So the chances are that your system is not going to be able to do an automatic warm start. That's probably going to get corrupted if you had to do a standalone dump. So you will have to enter force or some other kind of start, because we won't have, like I said, that data necessary to bring back up a warm start. And now I'm going to go back to my system. I'll log back on to Operations again. Now, this time it tells us that we started from a system IPL, because of course it has no idea that the thing we did before we did the load was a standalone dump. We did the dump to the standalone dump disk, so we're not going to see that in the reader of Operations or anything like that. Instead, what I'm going to have to do is attach my standalone dump disks right to Operations. And then I'm going to use something different on dump load 2. I'm going to use the DASD option. And it's going to ask me for the virtual address. Now, since I said just attach to myself and I didn't give it a virtual address that was different than the real address, I get to use that. You can see that, like I said, the standalone dump, the system wasn't doing that much, so it happened to fit all on one device. It's going to create a single file for that. Again, if you're really running a system that has sort of a usual load of lots of different guests, you're going to see this probably fill up multiple volumes. There, it created it. And there I can see when I do a dump summary, the ABN type is SAD001, so that stands for standalone dump. And again, it has the same kind of information. You see this enter wait state CPU mask. For all of these, that's, we did that stop all. That's all of the processors stopping. So that's not a part of the problem. That's something that we expect to see. But, if we do a VMD scan, we can see all of our same users, can look at all of them. That's all wrapped up there. So I'm going to mention that just because we don't fail often doesn't mean that you shouldn't be ready for it. So I mentioned about getting standalone dump set up in advance, thinking about how much spooling space. Hopefully you have some dedicated spooling space set aside for taking dumps. Soft dumps are something that I haven't really talked about here. They just happen when something comes up that we need to take a soft dump for. You can do a set add-in snap dump, and that will actually take a snap dump when you have a soft add-in, so it will give us a little bit more information. If you have a test system where you can do a set add-in hard, that will actually turn a soft add-in into a hard add-in that restarts the system. That's what we use in our own test floor here. Depending, of course, if you're running in production, please don't do that. But if you have a test system, you might want to do that. And like I mentioned, you need to have enough space for dumps, so you want to watch that dump option on CP owned. There will also be warning messages that go to the operator if something has happened and we don't have enough space to even allocate dump space. So that's sort of our estimate of how much dump space we'll need. And again, use set dump to control, this is on 7.1 and later, whether you dump PGM blocks or frame table, but just be aware that then we might come back to you and say, oh, we really need one with PGM blocks and frame table. Okay, there are a couple other things in this deck, and I'll just include them in the deck that we send out, but we also go through looking at wait states. So that can happen if CVM can't actually restart itself. There are instructions here for collecting monitor data if you don't have a separate monitoring product. And there are a couple other goodies and recommendations about what to do if various things go wrong. So I think at this point, I'm going to wrap up the presentation. Thanks.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.